Math with Mr. Williams, example 1, graphing ratio relationships. All right, so in A, we have flour to water. Okay, so for every 4 cups of flour, we need 2 cups of water, 8 to 4, and then 12 to 6. So down here in the graph, we have to remember our XY format. So if I have my X being my flour and my Y being the water, the first one would be 4 to 2, then 8 to 4, and then lastly 12 to 6. So when we graph those, we start at the origin, which is 0, 0. We move right to 4, and then up 2. For our second one, we do 8, 4, so we're going to move right from the origin to 8, and then up 4. And for the last one, we go from 12 and then 6. So we start at the origin to 0, 0, we move right to 12, and then up to 6. And you can quickly see the dots will create a line that goes to the origin. All right, on to B. So we have time and earnings. So for every 1 hour worked, someone's going to earn $10. 2 hours 20 and 3 30. So let's go ahead again. Let's make our quick table with X and Y. So we have 110, 220, and 330. All right, let's go ahead and graph it. We're going to start at the origin again, move right 1 and up 10. The second one, we start at the origin and go right 2 and then up to 20. And lastly, we have 330. So we move right to 3 and then up to 30. And again, it creates this line through the origin. These are proportional relationships. Math with Mr. Williams. Example 2, using a graph to solve a ratio problem. You buy dark chocolate cashews for $12.50 per pound. That is our unit rate. Represent the ratio relationship using a graph. Okay, so what I like to do when they give me a unit rate and I have to make a graph from it is I make a quick table. So we have our pounds and we have our money. Okay, so for 1 pound, it was $12.50. For 2 pounds, it'll be $12.50 times 2 would give me 25. And then for 3 pounds would be $12.50 times 3, which would get me $37.50. Okay, so let's go over and make a quick table regarding our XYs. Remember, X comes first from our table and Y second. So this would be 1, $12.50, 2, and 25, and lastly 3 and $37.50. All right, let's go ahead and graph it. So we start at the origin. We move right 1 and up to where $12.50 should be. Looks like it's between the 10 and 15. Then we go to 2 and go up to 25. Then we go 3 and $37.50, which would be between the 35 and 40. Let's go ahead and connect those. And you can see it is a proportional relationship because it goes to the origin and makes a line. All right, so let's go on to B. How much does 2.5 pounds of dark chocolate cashews cost? Okay, since we don't have any decimals in the play, as far as our poundage, we know that 2.5 is going to be somewhere between 25 and 37 because 2.5 is between 2 and 3. So let's make a quick ratio. So we have 1 to 1250, and we need to get up to 2.5. So we're looking for our answer for what times 1 is 2.5, which is 2.5. And so 1250 times 2.5 will give us our answer of $31.25. So if we come over to our graph, would that line up where 2.5 would be? So we go over where 2.5 pounds is, and we mark our way all the way up. And you can see it's just past the 30. So is it reasonable that that is 31.25? It is. So our answer of $31.25 for 2.5 pounds of chocolate makes sense. Math with Mr. Williams. Example 3, determining whether ratios form a proportion. Tell whether the ratios form a proportion. So we have 6 to 4 and 8 to 12. So what I like to do is to set them equal to each other to start. So what I like to do is to simplify both fractions. So I have 6 and 4. I'm going to divide 6 by 2 and 4 by 2. That'll get me 3 over 2. The question is, does that equal 8 over 12? So what goes into 8 and 12? I can see that 4 will go into both. 8 divided by 4 will give me 2. And 12 divided by 4 is 3. You can see these are not the same fractions, so these are not proportional. All right, on to the second one, we have 10 to 40 and 2.5 to 10. So let's go ahead and write those down. All right, and now I want to simplify 10 over 40. So I'm going to go ahead and divide that by 10 on both. 10 divided by 10 is 1. 40 divided by 10 is 4. All right, so I see 2.5 and I see 10. 1 is a decimal. I don't like to deal with decimals, so how do I get rid of a 0.5? Well, I'm going to first start off by making this larger by multiplying by 2 on the top and the bottom. So 2.5 times 2 will give me 5. 10 times 2 will give me 20. So now I have an equivalent format. Now I can simplify. So what goes into 5 and 20? Well, 5 goes into both. So I'm going to divide by 5. 5 divided by 5 is 1. And 20 divided by 5 is 4. So these are the same fractions. So these are proportional. Math with Mr. Williams, example 4. Using cross products, tell whether the ratios form a proportion. So we have 6 to 9 and 12 to 18. Well, same thing we did before. I'm going to make these into fractions and set them equal to each other. All right, now for cross products, we do this like Band-Aid / butterfly effect, and we write down our multiplication. So within the first one, we have 6 to 18. So we're going to multiply these out, and that should equal 9 times 12. So 6 times 18 will give me 108, and 9 times 12 will also give me 108. So these are proportional. All right, on to the second one. We have 2 to 3 and 4 to 5. Let's draw our Band-Aid or butterfly effect. Let's do 2 times 5, and that should equal 3 times 4. 2 times 5 is 10. 3 times 4 is 12. These are not equal. So these two ratios are not proportional. Math with Mr. Williams, example 5, determining whether two quantities are proportional. Tell whether x and y are proportional. All right, so we have a table, we see some fractions, we see whole numbers. The easy thing to see is the whole numbers going downward, 3, 6, 9, 12. That looks like a pattern. Question is the x also in the same pattern? Sometimes the easiest thing to do is to not start at the top. So if we start down here where there's 1, 6, now we can see what times 6 is 12. Well, that's just times 2, and 1 times 2 is 2. So at that point, those two are proportional. Now we have to worry about the fractions. So let's go back up. Let's start off with, we have 1/2 over 3, and I want to know if that's equal to 1 over 6. What times 3 is 6? Well, times 2. So is half times 2, 1. Let's just write that off to the side. So we have 1/2 times 2. That does get me 2 over 2, or just 1. So this does work. So that tells you that the 1/2 and 3 is proportional to the 1 over 6, and it's proportional to the 2 over 12. So now we have to worry about this one right here. So let's go ahead and start off with our original ratio. So we have 1/2 over 3. I need to get that equal to 3 over 2 over the 9. Okay, so what times 3 is 9? Well, that's times 3. So 1/2 times 3, does it get me 3 over 2? Well, let's find out. So we have 1/2 times 3. That will get me 3 over 2 for an answer on top. So it does work. So the table is proportional.